Chair now recognizes Mr. Brooks of Alabama.
Thank you, Mr. Speaker. Dr. Lewis, you pointed out that your lab has demonstrated a functional solar fuel system. Can you elaborate on the fundamental chemistry and materials research needed to discover new molecules and materials, and why that research is needed if you have already demonstrated at least one version of a solar fuel system?
Certainly. Thank you for that question. Demonstrating one version of a solar fuel system is, in our view, like the early flight of a Wright brothers. We can get off the ground, but we can't fly very far. We need pieces, we need materials that are as to an aircraft a jet engine is to that Wright brothers airplane in the first place. We need to simplify the system so that it doesn't have many so-called junctions. We need to get catalysts that don't use precious, expensive metals like platinum or iridium. We've made lots of progress there, but we still have a ways to go in order to get all of these pieces that we need all out of easily manufacturable, simple things that you or I could do in our garage, as opposed to having to have very esoteric laboratory preparations of them using expensive materials. And they also all have to be compatible with each other and last for 20 years, not 20 minutes. So we've demonstrated it's possible, but we still need to do a lot of fundamental material science and chemistry development to get it to be practical.
Okay, follow-up in that regard. Has the Department of Energy's Energy Efficiency and Renewable Energy Office provided adequate support for transitional or early stage research and development for artificial photosynthesis, or for that matter, a functional solar fuel system?
To my knowledge, EERE has not had a significant program yet in solar fuels. They do have related programs in consuming that fuel, and there are lessons to be learned. They should be trying out systems like our potential concept of bubble wrap that would concentrate the sunlight, just like the bubble wrap we receive, onto small areas, minimizing the amount of material that we would need, letting us use more costly material. There are other designs that are much more amenable to reduction to practice that are beyond the Office of Science's typical charter that would logically be built in EERE's domain so that we can solve problems that are problems and not solve problems that are not problems, learning from experience in a synergistic effort.
All right, this next question will be for each of you, and we'll start with Dr. Hallinan and move to my left, your right. How is the United States faring against international competition and foundational energy research? And each of you have talked about different subject matters, so if we could, your answer would be directed to your areas of expertise. Dr. Hallinan?
Thank you. So these upgrade proposals, they address mainly being able to look at complex materials on much smaller length scales and much faster times. And this is a new breakthrough in synchrotron science. It's already being implemented in Sweden, and there are plans to implement it in Brazil. So in that regard, I would say regarding the upgrade to our synchrotron light sources, the United States is a little bit behind. I think that really to look at polymer dynamics at the scale and at the rate that we need to, which is smaller than we can do now and is faster than we can do with our existing facilities. So I do think the upgrades are important in addition to maintaining our competitiveness from a research standpoint.
Thank you.
In my area of quantum materials, I think that the U.S. has a very lively program, and it has been characterized, I think, now by a stronger component of material synthesis, which is a really key part of development of quantum materials. I think comparing to other developed countries, sometimes one sees that looking, for example, to Europe, a more kind of organized approach to some of these topics. I think sometimes it's difficult to say whether the organized as opposed to the 1,000 points of lights is the better approach. I think things are going pretty well. If I could say something about the facility upgrades, maybe we'll return to it later, but the In terms of the neutron facilities, the spallation source is presently the world's most intense source of neutrons, pulse neutrons. But the European community is now building a spallation source also in Sweden, which will be a 5 megawatt source. And there's quite some concern among scientists who use neutron scattering that this facility will in fact surpass the spallation neutron source. And we believe that a upgrade is very important in order to sustain leadership in that area.
I don't know if the chair will permit, but I've got 2 more witnesses. Can they respond? Dr. Scherson?
Thank you. Yes, the only example that comes to mind that I'm fairly acquainted with is in Japan, where they have tried to emulate the EFRCs and HAPS programs that DOE is supporting in this country. The amount of financial support is lower than the one that the government here provides for these multidisciplinary centers. And one difference that perhaps may be considered is the integration of industry into the program. So now you have the beginning from the basic knowledge to the end user. And that has proven to be of value, so that by going from one extreme to the other one, this conversation makes it possible to take the good ideas and then migrate them very quickly into the marketplace.
Dr. Lewis?
Thank you. 2 points to speak to on this. One is I did mention that in solar fuels, there are burgeoning efforts now, very substantial, in Korea, Japan, China, Sweden, Germany, and the EU. And I'd say either individually or collectively, they're definitely on a par with what we are doing in the United States. The second perspective is I'm the editor-in-chief of the preeminent journal in this field, Energy and Environmental Science. That's a global journal. It's turning down 90% of the articles that are submitted. So it's very selective, and over half of those articles that appear in this field are from China, Japan, Korea, and our competition. We still have leadership, intellectual horsepower, but I think we're at a crossroads here, and we need to really understand that there are other nations who see opportunity for this scientific effort, and we have to make a decision as to whether or not we're going to continue to lead, and I hope that's a positive decision.
Thank you for your insight, Mr. Chairman, thank you for the additional time.